Alright guys, I'm going to try to finish this lesson up and then give you the answers for that worksheet. So, copy each of the following and mark them as rational or irrational. Okay? Now remember, rational numbers can be written as fractions. Their numbers will have a terminating decimal or a decimal that has a repeating pattern almost, like 333 or maybe 45 repeating, etc., etc. So, just looking at the root 3, a dead giveaway is the fact that this is a prime number. Okay? Remember, when we were breaking these numbers up into the factor tree and you had those leftovers, the fact that you have a number left over under a radical symbol pretty much means it's going to be irrational. I'm just going to use an I for this, okay? 17, that can be written as a fraction, so that's rational. Two integers on top of each other, we talked about that in class, that's rational. Yeah. I'm going to bite my tongue by the end of the night. Square root of 16 is 4, so that means that's rational. Pi, we discussed that in class, it's irrational. Pi over root 2, that's irrational, divided by rational, guess what? Irrational. 0 is an integer, so that's rational. And root 5, again, the fact that you have something under a radical and it can't be worked out, like this one, square root of 16 is 4, or even if you broke it up into the separate trees here, 2, 2, there's a pair, 2, 2, there's a pair, see, nothing left over, that's why that works out to be rational. This one has no pairs, it's a prime number under a factor tree here, it can't be broken down any, so yeah, this thing's got to be irrational. I'm going to flip the slide to check my answers, and boom. Indeed, I was right. Yeah, boy. Alright, moving on. Again, have you ever multiplied or added two rational numbers, integers or fraction, and ever gotten strange looking answers like pi, or this I means imaginary? That never happens. Okay, the product of two rational numbers is always rational. The sum of two rational numbers is always rational. Okay? Now, these next couple slides go into what we discussed in class about what happens when multiplying rational and irrational or even adding them. Okay, so whenever you have it mixed up with a rational and irrational or vice versa, it's going to be irrational. It's like working with like terms, and that's what this slide's about. You know, what happens when x is times 3? What do they equal? Well, 3x. But that's just a shorthand way of writing x times 3. 3 and x are not the same kinds of symbols, not like terms. So you can't make one number out of them. Okay? What is x plus 3 equal to? Unless you have a practical value to plug in for x, the only way you can write this answer is x plus 3. Or the answer is x plus 3. You can't combine x and 3 because they are not like terms. Okay, and y'all been dealing with this before. Multiplying and adding rational numbers with irrational numbers is the same way. They are not like terms, so you can't combine them and get an exact answer. Examples: 2 plus root 2 equals 2 plus root 2. There's no way to write the exact answer as one number or one symbol. 2 times root 2 equals 2 root 2. There's no way to write the exact answer as one number or one symbol. So, are 2 plus root 2 and 2 root 2 rational numbers or irrational? Well, this is rational, this is irrational, rational, irrational. Our notes tell us rational. Irrational. Man, this is such a tongue twister of a lesson. It'll be irrational, okay? Whenever you have a rational and irrational, rational, irrational will always be irrational. Okay? Moving on. What's the definition of rational? Again, rational numbers can be written as a fraction with integers on top and the bottom. Is that true for 2 plus root 2 and 2 root 2? The product of a rational number and an irrational number is always irrational, unless the irrational number is 0, so keep that in mind. the sum of a rational number and an irrational number is always an irrational number. So, again, just going back to this idea about the zero, maybe you may have to work the problem out a little bit before you can definitely say rational, irrational. Okay? You'll have some practice examples later. So, for example, try these out. Okay? So pause the video. You got 1 through 5 here, and see if you can't work them out. All right, we're back. So now we're ready to check your answers. This is rational plus a rational number. Our notes told us it has to be rational. This is irrational, and this is rational. It has to be irrational. Again, rational, irrational. Answer is going to be irrational. Look at here. The square root of 9 you know is 3. 3 plus 7 is 10. That's a rational number. 0.11, whoopsie daisy. 0.11 can be written as a fraction. So that means it's rational. Square root of 4 is 2. That makes that rational. Has to be rational. To check our work, let's check. Well, thought I had some answers on that slide. Just take my word for it. I think I might start teaching class with this calligraphy pen. Alright, now this was that worksheet you got before you left. So if you haven't done it, again, pause the video so you can try it out yourself and see if you get the right answers. When you're done, just hit play. Alright, we're back. You got a 10 plus 0.01. Again, you can write that as 1 over 100, which makes it rational. 10 is rational. These will make a rational number. 12, again, this could be written as 5 over 100. 12, both rational numbers. 15, I think you get the hint. That's rational. Same thing for that one, must be rational. This one, on the other hand, 7 can't be broken up. Okay? So root 7 is going to be an irrational number. This is a rational one. The answer will be irrational. Okay? Moving on. So try 6 through 10 real quick. Pause the video. Start it again when you're done. Okay, we're back. So root 11 is going to be irrational. 9 is rational. It must be irrational. Root 17. Again, if I'm not mistaken, 17 is also another prime number, but it can't be broken down anymore. So it's irrational. 5 is rational. Your answer is going to be irrational. Root 20, be careful. Let's see, 2, 10, 2, 5. The 2's will move out, but that 5 stays behind, which makes this whole thing irrational. So therefore, it must be irrational. Ooh, another trick one. The square root of 225, remember in class, was 15, which is rational. 625 is 25, so that's rational. So we have a rational number. Same thing for this one. Square root of 36 is 6. Square root of 64 is 8. These are two rational numbers. My answer must be rational. Alright, guys, that's it for these things. So, pretty stinking easy if you ask me. We'll do a review come, I don't know, maybe Monday. Okay? So, y'all have a good night. Have a good weekend. And video's only 9 minutes long. Alright, we'll catch you later.